Hello and welcome back. Today we're going to add rational expressions with like denominators, and you can see right here we have x plus 4, that's going to be in the denominator, and we just add whatever's on the top, so that's x plus 5. Or we can make sure we write the restrictions for the denominator, so x can't equal negative 4, because that will make the denominator equal to 0. Alright, before we start the next one and start adding, make sure first that we factor. So remember the first fraction, well, that will factor into 2x plus 1 over x squared plus 3x. So that we can rewrite that as x times x plus 3. When we add that to the next fraction, you can see that they have the same denominator. And so we can easily add those together. The denominator will equal x times x plus 3, and the numerator will equal 2x plus 1 plus 3x minus 8, so that'll be 5x. And then if we add the 1 and the negative 8, that'll be negative 7. So 5x minus 7 over x plus 3, and we know that x can't equal 0 or negative 3. All right, so we have common denominators, makes it really easy to add. Now, when we add fractions with unlike denominators, we have to find the LCD, or the least common multiple. So let's first look at these two polynomials and make sure we find the factored form. So x plus 2 quantity squared, that's already factored. So we can easily just write that as x plus 2 quantity squared. And x squared plus 5x plus 6, well, that factors into x plus 2, x plus 3. All right, so now to find the LCM, or the least common multiple, or LCD, we look at those factors. So we know that we definitely need an x plus 2. And we actually need to have 2 of them. So x plus 2 squared, to make sure that we have enough for both factors. We don't need 3, okay? We don't need 3 of those x plus 2's because that would be too many. We only need 1 for the one on the right and 2 for the one on the left. And then we need an x plus 3, so we make sure we write that factor as well. So that's going to be the LCD. X plus 2 quantity squared and times x plus 3. We'll have both factors can go into that LCM. All right, for the next one, let's look at these 3 polynomials and make sure that we first factor them before we find the LCD. All right, so x cubed minus 9x, well, that's x times x squared minus 9, and that's a difference of squares, so x plus 3, x minus 3. And now let's factor, well, there's a different color for this next polynomial, so that factors into x minus 5, x plus 3. All right, so you can set that aside. You can see it has x plus 3 just like the last one. And then for the third polynomial, well, that has a GCF of x, so x times x minus 5. Now let's compare the 3 polynomials, the 3 factors, to determine the LCM. We definitely need an x. See that in both the first and the second. We definitely need an x minus 5. We only need 1. That'll cover both of those factors. We definitely need an x plus 3. And then don't forget we have this x minus 3 over here. So that factored form is the LCM for those 3 polynomials. Each of those polynomials can go into x times x minus 5 times x plus 3 times x minus 3. All right, let's look at rational expressions that do not have like denominators. So for these problems, we have to first make sure that we factor the denominators and find the LCM. So when we look at this first fraction, it's x plus 3 over x plus 1 times x minus 1. There's a difference of 2 squares. All right, and we're going to add that with the second fraction, so that's 2, and that's going to factor into x minus 2, x minus 1. Now, when we look at those 2 fractions, we can see that we're going to have an LCM. So we're going to definitely need, if we put them together, we're going to need an x plus 1, an x minus 1, which is in both fractions, and an x minus 2. So now we're going to look at both of those fractions and convert them so they have the same denominator. So looking at the first fraction, well, it's missing the x minus 2. So we're going to multiply the top and the bottom by x minus 2. Now let's look at the second fraction. And that fraction's missing the x plus 1. So we're going to multiply the top and the bottom by x plus 1, which is really just 1. X plus 1 over x plus 1. All right, and from there, we're just going to start distributing and simplifying. So we multiply this top, so it's x squared, just FOIL, plus 3x, minus 2x, minus 6. And then looking at the second fraction, we're going to add this, and we're going to distribute the 2. So we'll have 2 times that x, and then 2 times the 1. So we'll have plus 2x plus 2. All right, from here, we've added the fractions, and now we just need to simplify. So let's combine like terms. So we don't have any more x squared, so just 1x squared. Add those together, we'll get plus 3x. Add the negative 6 and plus 2, that'll be negative 4. And then over our factored denominator, x plus 1, x minus 1, x minus 2. Now this one is a little tricky because the numerator factors again. And so we can actually factor that into x plus 4 times x minus 1. And when we write the denominator, you can see that we're going to have things that cancel. So let's just start canceling out common factors. And so on the bottom, we're going to get x. Oh, I definitely made a mistake here. So let me just fix this. All right, I should have just canceled out x minus 1. I hope you guys caught that. All right, so we're going to have x plus 1 left in the denominator and x minus 2. And remember, x can't equal negative 1, plus or minus 1, because we already canceled the negative 1 and 2. All right, so just going over these steps, make sure that you first factor the denominator. We always want to find the LCD. All right, so we factor them and then put them all together. And then we're going to just combine like terms. So you may have to FOIL, you may have to simplify, okay? But if you simplify, just double check if things reduce in the numerator and denominator. All right, let's go to the next example. It's very similar. We're just going to use subtraction now, but the first step is always to factor the denominators. So let's look at the first fraction. So we have x plus 1, and the denominator is going to factor into x minus 8 times x plus 2. And then we're subtracting this, I'll put a minus sign, and the second fraction is x plus 1, and that's going to factor into x plus 4, x plus 2. All right, so now we have to make sure we find the LCD. So we look at the denominators and make sure that we write them together. So we're going to have an x minus 8 and x plus 2, which is in both of those fractions, and an x plus 4. And so let's go back to each fraction and make sure that we convert it and see what's missing. So the first fraction is missing an x plus 4. And the second fraction is missing the x minus 8. And then from here, we just have to simplify. So I'm going to multiply x plus 4 times x plus 1. So that's x squared plus 5x plus 4. And then I'm going to subtract. So I'm just going to be careful with that and put a parenthesis here. But x plus 1 times x minus 8 is x squared minus 7x minus 8. All right. So now we're going to combine like terms. And you can see that the x squareds are going to cancel out. So let me just write the denominator here first. All right, so we have x squared minus x squared. That's going to go away. We had 5x minus a negative 7x. So that's going to be 5x plus 7x. So So that's going to be 12x. And then we have 4 minus a negative 8, which is plus 12. So we can double check and factor. So 12x plus 12 factors into 12 times x plus 1. But nothing cancels there, so I don't really need to factor it. All right, let's look at our next problem here. So whenever you're considering rate, we want to make sure that we're looking at these values and using variables, the DRT. So we know that the train is going 15 miles per hour faster than the car. So the rate or the speed of the train is r plus 15. And in the problem, Leah is taking this 10-mile round trip. So I'm going to organize the information, and we always want to make sure we're using distance equals rate times time. And so I'm going to sort that information into a table. So let's first put the information down for the car. And I'm going to make these little columns so I can start organizing my data here. All right, so we know that the car is going 10 miles, and that's the distance. I'll put 10 for D. We don't know the rate. Well, we actually do later, but I'll put R right there for its rate. And then the time, well, we can express the time as 10 over R. Because remember, we're looking at this equation. If we isolate T, we can divide both sides by R. So D, distance over rate, equals time. All right, let's find the information for the train. So looking at this train, it's going the same distance. Leah's going to cover 10 miles there, but the rate's a little faster, so R plus 15. So we can express the time for the train as 10, the distance, divided by the rate, which is R plus 15. All right, the question's asking how much total time, what's the total travel time? So we have the time for the car, 10 over R, and we have the time for the train, 10 over R plus 15. And now we just have to add them together. So you can see that we have an LCD, it's going to be R times R plus 15. Let me just write this below so we have more room. So, because I know I'm going to have to convert each of those fractions. All right, so let's look first at the 10 over R. So we're going to have to multiply that by R plus 15 over R plus 15. And then the second fraction, well, that's missing an R. So I'm going to multiply that by R over R. So we get 10R plus 150 plus 10R. All right, so let's add those together. So we get 20R plus 150 over R plus 15. So that expresses the total time in terms of R. In this problem, they gave us if she drove 30 miles per hour, if her rate was 30. So we can plug in 30 for R. So wherever we see R, we'll put a 30. So we get 20 times 30 plus 150 over 30 plus, or 30 times 30 plus 15. And we can simplify that. So you can multiply that out and reduce it, and we'll get 5 over 9. So that means that it's going to take 5/9 of an hour, because everything is miles per hours. And when we multiply that by 60, that's about 33 minutes. So 5/9 of an hour, or 33 minutes for that total travel time. All right, let's look at the next one. So for this last example, we're going to look at compound fractions, meaning we have a fraction inside another fraction. So the easiest way is just to look first either at the numerator or the denominator. So if we look at the numerator, well, you can tell that that's going to have an LCD. Its LCD is going to be x times x plus 1. So I'm just going to write the numerator here, so x times x plus 1. Looking at that first fraction, it's missing the x plus 1. So x plus 1 over x plus 1. The second fraction is missing the x, so I'll multiply the second fraction by x. All right, so now we need to just distribute, so we get x plus 1 plus 2x in the numerator. And then we're going to divide that by 1 over y. All right, so we can simplify this. So we have 3x plus 1, so x plus 2x, over x times x plus 1. Now remember, division is the same as multiplying by the reciprocal. So multiply by y over 1. And so from here, all we have to do is multiply across. So we have the 3x plus 1 times y. I'll put the y out in front, make some room there. And then we'll have x times x plus 1. And nothing cancels, so we're just going to leave that expression as our final answer. Okay, so just to review what we covered today, remember we were looking at adding and subtracting rational expressions. So if we have a common denominator, so something like a 5 in just a regular fraction, remember you just have to add the numerators. So 1 plus 3 gives you 4. And you do the same thing when you have a rational expression. So if we have x plus 4 is the common denominator, just add the numerator, so x plus 5. When you don't have a common denominator, here you have 6 and 15, you have to find the factors, and then the LCD or LCM. So we know that we could find that with the factors, and then we have to convert each fraction to have the common factor. We do the same thing with rational expressions. So make sure that you factor those polynomials, find the LCD, and then you can add and subtract.